Hello, everyone. I trust you can hear me and hopefully see my screen as well. My name is Jeff Procyse. I'm a founder of Wintellect and will be doing the presentation for you today. If I can figure out how to get this little guy out of here. Oh, well, we'll just put him way down there where no one can see it. So to make sure you're in the right place, our webinar today is entitled Building Intelligent Apps with Azure Cognitive Services. My name is on the cover slide there, along with my email address and my Twitter handle, so that if you have any comments or questions or whatever, you can reach out to me and contact me, and I'll do my best to help you. Just a couple of things housekeeping-wise before we get started. Again, I'm a co-founder of Wintellect. We are a software services company that helps companies build software. We help them learn how to build software. We've trained about 40,000 developers of Microsoft over the years, and we help companies migrate infrastructure to Azure and then manage that infrastructure for them. So at any given time, we typically have a few offers out there, so that if you want to get some time with us to look at what you're doing in Azure or something, assess what it would take to do a deployment or something, we'll do that for you absolutely free. Some information here on how to access those, and I'll make sure that you have a copy of the slides here at the end of the presentation, along with some cool sample code, by the way, so that if you want to follow up on any of this, you can just reach right back out to us. So let's get started, because we only have about an hour together, and I could literally talk about this subject for hours and hours and hours. In fact, if you talk to people at Wintellect, they'll tell you that sometimes I do. So the subject of our time together is a set of services and APIs that are part of Microsoft Azure called Azure Cognitive Services. And the big picture here is this. There is much that we can do these days with machine learning and AI, artificial intelligence, to enable us to do things in software that would have been difficult or impossible just a few years ago. In fact, one of the things that I do at Wintellect is work with companies to understand what machine learning and AI are and how they can utilize these technologies to solve business problems, build smarter software, et cetera. And when I work with companies to do that, we go through the fundamentals of machine learning. We go through deep learning, building neural networks to do crazy things. But at the end of the day, there are certain things that are possible with AI today that it's simply not practical for you and I as software developers and engineers to do. As an example, it's not difficult for you and I to build a machine learning model that does sentiment analysis, that looks at a tweet or a comment left on a website and score it for sentiment, give it a number between 0 and 1 indicating how negative or positive the sentiment expressed in that text is. That's not hard to do, and it's a pretty well understood science in machine learning. But what if you wanted to do something different, something a little bit more challenging, like build software that does real-time translation of speech from one language to another? AI can do that today. In fact, there are proven models built from neural networks that do it. But that kind of model is so sophisticated and requires so much compute power to train that it's not practical for you and I to build that kind of model. That's where Azure Cognitive Services come in. It's a set of about 25 services and APIs that let you do magical things in software using machine learning, AI, and neural networks. Some of the things that it does, like sentiment analysis, yeah, you could do on your own, although it probably does it a little bit better. But other services that it offers embody features that it simply is not practical for you and I to do, like real-time translation of speech, high accuracy speech to text, looking at photos, identifying objects in those photos, captioning the photos, detecting adult or inappropriate content, things like that. So the whole idea behind Azure Cognitive Services is Microsoft has an entire division called Microsoft Research, in which they hire some of the smartest people on the planet, expensive data scientists here and in other countries. They build incredible models. and then they expose those to us and our software as APIs. Now, to an extent, it costs money to use these APIs, but what you'll find is that most of the APIs have a free tier. So when you're just developing around these APIs or making light use of them, it doesn't cost you a thing. It's only when you're making hundreds of thousands or millions of calls to one of these APIs a month that the meter starts running. There are versions of some of the cognitive services APIs that are completely free. And over time, I think you'll probably see more and more of them become freely available, in part because of competition. Microsoft has Azure Cognitive Services. Amazon has a similar suite of intelligence as a service services, as does Google and a few other companies. So as those companies compete with each other, they're continually lowering prices, making things cheaper and stuff like that. And you and I, as consumers, benefit from that. Now, on this slide, I've listed the different services and APIs that belong to Azure Cognitive Services. I won't go through all of these in the hour we have together, but I have picked out ones that I think that might be the most useful to you, and built some examples so you can see exactly what cognitive services are, what kinds of things you can do with them, and how you write code to leverage these cognitive services. At the end of the presentation, I'll also point you to a public repo that I maintain on GitHub where you can download the examples that I show, and some that I won't be showing as well. So let's start with one member of Azure Cognitive Services, which is the Computer Vision API. The upshot of this API is that it lets you submit images to it, and it analyzes the images and can tell you all sorts of things about the images. It can identify objects in the image. It knows about thousands of different kinds of things, from basketballs to butterflies, that it's capable of identifying. It can caption the images for you using AI. It can identify faces in the image and tell you things about those faces, like the age of the person, the gender of the person, whether they're wearing glasses, whether they have hair or they're bald, etc. And it can do a lot of other things as well. For example, if you submit to this API a photo that has text in it, maybe it's a picture you snapped of a road sign, it can extract the text from it. It can do other things. It can grade a photo for inappropriate content. It can generate what we call smart thumbnails, basically taking an image, resizing it to the dimensions that you specify, but using AI to identify the focus or the subject of that image and doing the cropping so that it retains whatever is the subject. I actually use that capability quite a lot when I need training images for neural networks. I'll use Bing search to find the images, then I will use the Computer Vision API to size all those images to the same size, the size that I'm going to input to my neural network, knowing that because I use the smart thumbnails capability, it's going to retain whatever is the focus of that image. So here's an example. Using the Computer Vision API, all of these APIs are REST APIs, which means you can use them from any programming language you want to. As long as that language allows you to put an HTTP request on the wire, you can invoke a Cognitive Services API. It could be C, C++, Java, Python, JavaScript, whatever you want. Here's an example of the call that goes out on the wire, independent of language. If you wanted to take an image like this one and score it for potentially inappropriate content, notice I'm doing an HTTP post to a particular URL up there. In the the OCP APIM subscription key header, I pass a subscription key, which I obtain from the Azure portal. That's how Microsoft knows if there are charges due for my calls to these APIs. That's how it knows which Azure subscription to do the charging to. Then in the body of the HTTP post, in this case, I specify the URL of the image. You can also pass the image itself encoded in the body of the HTTP post. And what you get back when you make that call is a bunch of JSON. In this case, that JSON includes a pair of scores, something called an adult score and a RACI score. These are values from 0 to 1, measuring the photo's adultness and its raciness. So RACI score, that photo on the previous slide, had a lot of skin in it, so it got a pretty high RACI score. But its adult score is low because AI determined that there was no nudity in that photo. By the way, they are in the process of enhancing this API to also include a goriness score, so that if the photo contains a lot of blood or other things that you might not want to expose to your users, you can score that using AI as well. But that's not all you can do with the computer vision API. Here, I'm calling the same API, but this time I'm asking it to caption the image for me. So as an example, I took this photo of me a few years ago sandboarding in Dubai, and I submitted it to the computer vision API this way. And what I got back was a bunch of JSON that contained a caption for the image, a man riding a skateboard in the sand. That JSON that was returned also included some tags, basically words identifying things that the computer vision API saw in the image: a man, dune, board, hill, sand, etc. That's really useful if you wanted to make a database of images searchable. You could submit them to the computer vision API, store those tags or keywords or metadata that comes back, and then base your search functionality around that. Now, there are other things you can do with this API as well, but let me also mention that even though all cognitive services APIs are REST APIs that can be called from any language, Microsoft also produces free SDKs for a lot of popular languages like C# and Python and Java and things like that. So if you want, rather than deal with raw HTTP requests where you're creating JSON to put on the wire, you're parsing the JSON that comes back, you can use these SDKs and do all of this in just a few lines of code with all the parsing and generating of JSON done for you. As an example, my preferred language is C#, even though I seem to be doing more Python than anything these days. But if I'm a C# developer and I want to call the computer vision API, in Visual Studio, I can add the NuGet package that Microsoft has published for the computer vision API, and then I can call it using types in that package with code like this. I begin by creating a computer vision client object that allows me to make calls to the computer vision API. And when I create it, I specify that API key or subscription key that I obtained from the Azure portal. I also provide the URL or service endpoint that comes from the Azure portal. Then, in this case here, I'm calling the computer vision client object's analyze image async method, providing an image URL. There's a different form of that method that allows me to pass in the actual image itself rather than a URL. When that call returns, then I can look at the results that come back, and I don't have to parse the JSON myself. If I want to get a caption, for example, that was in that return JSON, I can do it using the for each loop you see at the bottom. Why is it a for each loop? Because the computer vision API will sometimes generate multiple captions for you. And for each one of them, it gives you a confidence score so that you can tell which caption it had the most confidence in. So let me show you an example here. I'm going to pop over to Visual Studio. This is one of the examples that I'll give you that you can pull from the repo. I'll give you a URL for it. And let me zoom in just a bit there so that you can hopefully read what's on my screen. This sample is called IntelliPix. It's an ASP.NET 5 example that actually this one may be running against ASP.NET Core 3.1, but I have recently updated it to ASP.NET 5. But what it does very simply is this. It lets me upload a photo. So let's upload one. Let's see here. Let's go over to my pictures folder. We'll just pick out something that looks like fun. How about go to favorite travel photos. There we go. And I'll just grab, I've never tried this one. Picture I took in Israel a few years ago out in the middle of the desert where I ran into some camels, something that I don't think I'd ever done before. So the image is uploading and a call is going out to the computer vision API asking it to do two things. One, to caption the image for me, and two, to give me search metadata, keywords, or tags that I might use as the basis for a search feature. If I click that image, I'll see an enlarged version of it, and I'm not sure why this is taking so long to come up, but when it does, you see at the bottom here, the caption that the computer vision API generated for the image, a couple of camels sitting on a sandy area. That's pretty remarkable when you think about it, that a computer can look at this image and assign it a caption like that. To show off the search feature, let me go find a couple of more images. Here's one with some water in it, for example, and most likely search metadata generated for this photo will include the keyword water. I know that for a fact, but I'm guessing that it will. And let's go grab another one, maybe one that contains some water like this one right here. Now, what I'm doing with these photos when they're uploaded is I'm storing them in Azure Blob Storage. When you create a blob in Azure, you can also add metadata to the blob. So I'm adding metadata to each blob that I create in Azure Blob Storage, and in that metadata, I'm storing the captions that were generated for the image and all of the tags, the keywords that were generated. If I go up here, I'm just going to type in water, and what this is going to do is search through all of these image blobs in Azure, looking inside the metadata that I stored for them, and it's going to return a match for any images whose metadata contains water. So it looks like the computer vision API saw water in two of these images. One is a photo I snapped in Hilton Head last year. It was captioned a body of water with a dock and a building in the background, pretty cool. And this is a photo from Isle of Skye, Scotland, one of my favorite places in the world. Don't know how it was captioned, but does appear that my connection is pretty slow now. A cliff with a body of water and the road on the side. Again, pretty remarkable if you ask me. So what did it take to build that application? Not too much. I started by adding to the project the NuGet package that gives me a really nice C# wrapper around the computer vision API. Then if you look through the code, here's where a lot of the action happens. This is the method that's called when a photo is uploaded to the website. And initially, I just do a few things to store that photo in Azure Blob Storage. I also create a thumbnail version of it that I store in a separate container in Blob Storage. But then, here's where the computer vision API gets involved. I create a computer vision client object that allows me to call the API. I grab the parameters like the API key that I got from the Azure portal from appsettings.json. Then I make the call out to the computer vision API to its analyze image async method, and I'm passing the URI of the photo in blob storage. Then when it comes back, I'm taking the first of potentially several captions that were generated, as well as the tags that were generated, all those words describing the image, and writing those to Azure Blob Storage so that if the user does a search, I can go pull up the photos that have metadata matching that search term. So thanks to the computer vision API, took very little code to add that functionality in there. And that is just one example of the kinds of things that you can do with this API. Excuse me. So let's move on a bit here and look at another one of the Cognitive Services APIs, which Microsoft calls the Face API. So if you ever wanted to write an app that does what the Uber app does, for example, that looks at a face in front of your phone and compares it to a face in a photo to tell you if they're the same person, Uber does that as a security measure to help you make sure that the driver who picked you up is the person who was supposed to pick you up. If you wanted to build something like that, you could either spend a lot of time learning about facial recognition, all the technologies involved, or you could use Cognitive Services Face API to do it. So it too is a multi-talented API. In short, the things it will do is it will look at a photo, find the faces inside it, tell you where they are, and give you information about the landmarks on the faces, like the eyes, the nose, the mouth, and things like that. But it can also tell you more about the faces in the photo. It can tell you their age, their gender, the emotion expressed on the face. I think there are 8 different emotions that the API supports, like fear, happiness, neutral, things like that. And it can tell you more about their face, like whether they're wearing glasses and things like that. Another thing it can do is it can take 2 photos, each with a face, and it can tell you the likelihood that those faces represent the same person. And finally, it allows you to build facial databases. Maybe there are 100 people that work in the building you work in, and you want to build a system, a security system that will unlock the door only if they are one of the people that work for your group. You could train a face database with a few pictures of each of the 100 people, then have them stand in front of a camera outside the building, take that photo, call into the Face API and say, does the person in this photo, does this face match any of the faces in the database? And if so, what is the degree of confidence? So with a couple of function calls, literally, you could build that security system that opens a door only if that person is someone who is authorized to enter the building. So what does it take to call this API? Well, I'm going to do this example and many of my others in C#, but do remember you can do this in any language you want. And in C#, I begin by installing in my project the NuGet package that Microsoft created to wrap the Face API. From that package, I create a Face client object, specifying the API key that I obtained from the Azure portal for that API. And then I call on that Face client object, detect with URL async, and I can pass in either an image URL or the actual image bits themselves. And called this way, the API does something very simple. It finds all of the faces in the image and returns to me a collection of face rectangle objects telling me where in the photo that face is. This example that you see in the lower right corner, that's a picture of my youngest daughter when she was headed off for a summer study abroad a couple of years ago. There was only one face in the picture, and you can see that the API told me exactly where that face is. By the way, it'll find any number of faces in a picture. You can also ask it to give you more information about those faces. Here, I'm making the same call to the detect with URL async method, but I'm also passing in a list or collection of face attribute type objects that tell the API what I'd like to know about this picture. Here I'm asking for the gender and the age of the faces in the picture. There's more I can ask for as well, but these are the 2 that are probably used the most often. When the call comes back, in my for each loop, remember that this works with any number of faces. I can go through there, I can enumerate the faces that were detected in the photo and get the gender and the age of each face. And I'll show you an example in just a moment that does exactly that. Now, something else you can do with this API is have it compare 2 faces. Take 2 photos and have it tell you the likelihood that that the same person belongs to those 2 faces. So all you have to do is first detect a facial image in each of the 2 photos. You get back a face ID for each one. You pass those 2 face IDs to the verify face-to-face async method, and it gives you a Boolean return that's either true or false, saying whether these the photos are identical or belong to the same person. But it also gives you a value between 0 and 1, expressing a confidence level. So you might say, hey, forget about the is identical thing. It uses a threshold of 50%. I'm only going to honor this if the confidence level or likelihood that the 2 faces belong to the same person is 90% or higher. So you could make that judgment based on the confidence property that's returned to you. If you wanted to go further and create an entire facial database representing a group of people, you could do this. Here, I begin by creating a person group, kind of an awkward term, but it's called a person group in this API. Then I add persons or people to the person group. And for each person that I create in the person group, I upload facial images or photos containing pictures of that person's face. Now, in this case, I'm adding 2 people to this person group, myself and my wife, and I'm uploading 2 images of each. Obviously, the more images you can provide for each person, the more accurate the API is at identifying people. But it is remarkable how well it can do sometimes with just 3 or 4 or 5 images of a given person. Once I've created the person group, added people to it, uploaded the images, I call train async to train a neural network around this. And the cool thing is later, if I want to add additional people or additional faces, I can simply get a reference to this person group, add the people or the facial images and call train async again, and it will pick up right where it left off and train with the facial images that I've uploaded since the last call to train async. Once you have that facial database trained, then you can take some arbitrary image, detect a face inside it, notice the call to detect with URL async, and then you can call the identify async method to see if any of the people in that person group match the person in the photo whose face you just detected. And what it will do is give you back a collection that you can iterate over with for each. It will tell you all of the people in the person group that it thinks could be the person in the photo, and it will give you a confidence level for each one of those. It actually works remarkably well in practice. Let me show you a quick example of the Face API in action. To do that, I'm going to open a different project in Visual Studio. This one is called Face Detector. And it's a pretty simple one. It doesn't train a person group or anything like that. By the way, you can see my API key there. In the versions of these projects that I store in my GitHub repo, I have placeholders for the API keys and URLs to actually run these samples. If you download them from the repo, you'll need to go out to Azure and get your own API keys for the various APIs that I'm using. But when I run this one is a Windows 10 app. I click select image, and I'm going to go find a picture here. There's a particular one I'm looking for if I can find it. Here we are. Picture of my wife and my youngest daughter. This is the one that was in the picture a few minutes ago. She was much younger then. The Face API found 2 faces in that image, but I also asked it to give me more information about the faces that it finds. So if I click one of those faces, my daughter, for example, it tells me that that appears to be a female. Looks like she's 6 years old. Let's see. She was actually 7 at the time this was taken, I believe. And she has no beard or mustache, no glasses, and there's an expression of happiness on her face. Now, it'll do the same for my wife. Of course, she would kill me if she knew I was doing this, because that age 42, that's pretty accurate. That's within a year, I believe, of the age she was when the picture was taken. So we're not identifying faces here. We are finding faces and asking the API to give us information about those faces. It's just one of the things that Face API will do. But again, there are other things you can do as well. So let's go back to the slides here and tackle our next Cognitive Services API right here. This is one that in my experience doesn't get talked about that much, but it's one that is incredibly potentially useful. Suppose you are building a robot, and that robot needs to be able to identify objects within its field of vision. Maybe you work for a manufacturing company and you have products rolling off an assembly line, and you want to write code that will look at photos of products as they roll off the assembly line and alert you if one of those products is defective. Or maybe you want to do something else entirely. I built a fun little example from Microsoft a while back in which we take cameras positioned throughout the Arctic, motion-activated cameras that snap pictures of wildlife, upload the pictures to blob storage. Then we use AI to identify the wildlife in the pictures. We were particularly interested in polar bears because we can use that information if there are enough cameras positioned around the Arctic to get some idea of how many polar bears are being spotted, where they're moving, and things like that. All of that and more is possible with the computer, or rather the custom vision service in Azure Cognitive Services. Now, before I show you an example, let me tell you a little bit about how this thing works. Computers, thanks to AI, have gotten very good at computer vision tasks, especially image classification tasks. Computers can now outperform humans at looking at a photo and identifying objects inside it. And the reason that AI is able to do that today is because of a special type of network called a convolutional neural network. If you've never been exposed to CNNs before, they consist of a stack of convolution and pooling layers followed by conventional fully connected layers of neurons that use the information extracted from the convolution and pooling layers to identify the objects and images. Now, the purpose of the convolution layers is to do some image processing on the images that we train with and we ask the network to do predictions with. In fact, the technology that it uses goes back 50 years. If you've ever used Photoshop to emboss an image or sharpen an image, Photoshop is using something called a convolution kernel. It's basically taking a little matrix like the one you see on the right, the ones with the zeros and the negative ones and negative twos and ones and twos in it. It's passing that matrix over every pixel in the image, multiplying the pixel underneath the cell of each cell of the matrix by the value in the matrix, then replacing the pixel at the center of the matrix with the sum of those products. If you take a simple kernel like the one you see in this slide and run it over every pixel in that hot dog image you see at the top, what it produces is the monochrome image at the bottom. In neural network terms, we say that we have extracted features from the image because we've basically done edge detection and pulled out patterns that might be indicative of a hot dog image or an image containing a cat or an image containing a defective part or something else. So you and I can build convolutional neural networks from scratch. Libraries like Keras and TensorFlow make it relatively easy to do. However, in order to build a very sophisticated convolutional neural network that can identify thousands of different kinds of objects, we typically need to train with millions of images. And that's going to take years to do unless you can afford to spin up a cluster of graphics processing units or Azure and AWS or buy 10 or 20 NVIDIA GPUs to train them on locally. However, companies like Microsoft and Google have already done a lot of this for us. They have built some super sophisticated convolutional neural networks, trained them with tens of millions of images to recognize all sorts of different objects. And they've put these trained networks out in the public domain in GitHub and other places so that you and I can use them. That means if we need a super sophisticated CNN that can look at a photo and determine whether one of the objects that CNN was trained to recognize is in the photo, we don't have to build any neural networks. We don't have to do any training. We just download the networks that these guys have already trained. However, that doesn't do you any good if you need to use a sophisticated CNN to handle very domain-specific tasks, like looking for a particular type of polar bear or something, which most likely these pre-trained CNNs were not designed to look for. Enter a technique called transfer learning. Transfer learning is absolutely magical, and it's one of the most important things that have happened in the field of computer vision in recent years. What it allows us to do is to take these super sophisticated convolutional neural networks already trained by companies like Microsoft and Google and repurpose them, not retrain them, but repurpose them to solve domain-specific problems. So transfer learning, for example, allows us to take a CNN like this one. This was 6 years ago. This was a cutting-edge CNN that won a famous competition called the ImageNet competition. They're actually much deeper and more sophisticated today. What it allows us to do is take the so-called bottleneck layers of that CNN, the layers that extract the features from the images using convolution kernels, and downsize the images with pooling layers so they can recognize different features at different resolutions, and strip off the classification layers that tell the network what those features represent. Instead, we train our own classification layer at the end so that the network can recognize objects we want it to recognize in addition to the ones that it was originally trained to recognize. The nice thing about transfer learning is it allows us to use the smarts built into the network when it was trained by Microsoft or Google, but with very little compute power required, repurpose the network to recognize things that are specific to our domain. Transfer learning doesn't require a bank of GPUs out in the cloud. You can normally do it with 2 or 3 minutes training time on an ordinary PC or laptop. So how do you do transfer learning? Well, there are lots of ways to do it. If you're a Python programmer, you can use Keras and TensorFlow to do it. It's one of the things that we teach people how to do in the ML and AI class that we teach here at Wintellect. If you're a C# developer, Microsoft has an awesome free open source cross-platform machine learning library called ML.net that makes transfer learning easier than any other library I've seen. But you can actually do it today without writing any code whatsoever by using Azure's custom vision service. I'm going to demo this for you in just a moment. You'll see that we just go to the custom vision portal on the web. We upload the images that we want a network trained with. We specify the tags for the images. We click a button and it goes off and uses transfer learning to build a sophisticated convolutional neural network for us that is trained to recognize whatever objects we want it to recognize, which don't have to do, aren't required to have anything to do whatsoever with what the network was originally trained to recognize. Once you've trained the model, you make calls to it using code like this right here. So you can make calls out, you can invoke the model, submit a photo, ask it to tell you about that photo, for example, and everything about it is domain specific. Let me give you an example here. Let's open a browser. And I'm going to pop out to the Custom Vision portal, which lives at customvision.ai. And it'll ask me to sign in. I'll sign in with my Microsoft account right here. And in a moment, it'll take me to a page that shows the projects that I've created and allows me to create new projects. Waiting for it here. I don't know if it's slow or my connection is slow. Could be my connection. So a little bit of background. My daughter is getting married next month. She has a wedding shower this weekend in Knoxville, Tennessee, where I live. So she's here this week, and she is upstairs doing her job remotely. She works for Garmin as a software developer. So she's in a meeting right now. My son works for Delta Airlines. He is working remotely for a short time as well. He is also upstairs in meetings with Delta, and I'm down here doing the webinar. So we may be saturating the connection, although it seems like this has taken way too long. Let me try logging in again here just to see if that'll come back a little bit sooner. Whoops, we can't find the page you're looking for. Maybe a problem with the custom vision service. We'll try one more time. Okay, it's going to ask me to tell it who I am. And here we go. We got through that time. Although I had a project created here that seems to no longer be here. That's okay, we'll just create it anew. So I'm going to create a new project here. We're going to call it, how about Webinar Vision or something like that. And let's see here. We're going to ask it to use transfer learning to build a sophisticated convolutional neural network that does image classification. And I'm going to choose the general domain. Basically, Microsoft has different pre-trained CNNs that it can leverage with transfer learning to repurpose them to do whatever you want them to do. If you were doing something like looking at animal images or something, since there's not a domain for that, you would just select general. I've actually found I often get better accuracy just by choosing general, no matter what type of objects I'm going to have it look for in images, than if I pick one that is specific to the domain. So we're going to create a project here. Actually, we need to do this. Let's create a new cognitive services resource. And I'll call this a webinar hot dog. How about that? I'll choose an Azure subscription. Well, yeah, we'll put it in a new resource. Actually, I'll just put it in an existing resource group and delete it later on. So I'll put it in my cognitive services resource group. Everything else should be fine. There is a free tier, but you can only have one per subscription. So it's going to force me to choose a paid tier, although you don't pay anything until you exceed some limit of calls per month. So it's not going to cost me anything to do this. And hopefully this will create the project for me and let me get to the work of uploading and tagging images. Now again, what I'm about to do, I could do in C# with ML.NET, or I could do in Python with Keras and TensorFlow. But here I'm going to do the same thing in the custom vision service without having to write a single line of code. So it's asking me to upload images that I want this CNN to recognize. So let's pop over into my GitHub folder. I've got some images in mind. Let's see here. We will try this one right here. So I'm going to start by uploading 50 images of hot dogs that I basically just randomly pulled off the internet. And I'm going to tag those with the word hot dog. So those images are uploading. Now I'm going to do the same with some other images. I'm going to click add images again, and I'm going to upload 50 pizza images, also pulled from the internet. And I'm going to tag them with the words pizza. And once that's done, I'm going to do this one last time to upload 50 sushi images that I pulled off the internet. So let's go grab those. And by the way, there's nothing magic about the number of images I'm uploading. This service can sometimes do a really good job with this as few as 10 or 20 images of each class or different type of thing you wanted to identify. 50 usually gives it more than enough information to be able to very accurately identify images that belong to these three classes. So once I've uploaded, in this case, 150 images, 50 of each of three classes, hot dog, sushi, and pizza, I click train, and then I sit back for a few minutes while a new neural network gets created in Azure. And using transfer learning, it is repurposed to use the smarts from a network already trained by Microsoft, but to recognize the domain-specific images that I've asked it to recognize. So rather than wait for it to train, I'll just tell you, typically takes 3 to 5 minutes or so. Once it's done, a link appears that allows you to publish this as a service that is callable over the internet. So I've already built a model like this, and I'm just going to bring up a client here in Visual Studio that allows me to invoke that model. And let's see, I called it not hot dog. So let's run it first. And what it does is very simple. It allows me to upload an images to it, and it tells me whether that image contains a hot dog. So here's a photo I snapped on my deck last year one day at lunch. It was a beautiful day. I grilled hot dogs for me and my wife. And I snapped this photo with my phone and said, you know, I can probably use this in a class or webinar sometime. And based on a model identical to the one that I just created with a custom vision service a few years ago, it believes with 100% accuracy that that photo contains a hot dog. Now, what if I pass in an image of some sushi? I took this at a Microsoft office in Australia a year and a half ago. I'm not showing all of the data that comes back from the call. It did tell me that it believes with, I believe, 99.9% accuracy that that is an image of sushi. I'm just showing, nope, it's not a hot dog, and we are basically 100% confident in that. So it's a somewhat whimsical example, but no tool I've ever seen makes transfer learning as easy. So any kind of job that involves image classification this way, whether it's looking at a photo and identifying the type of dog in it, or the type of butterfly, or defective parts coming off an assembly line, as long as you can scare up some images of each of the different classes, like defective or not defective, or collie versus labradoodle versus poodle, you can easily train up an accurate model and invoke it from a client, as I'm doing here. And in fact, the code that actually submits the image to my custom vision service model to analyze it is simple. I create a custom vision prediction client, and I call its classify image async method. What it actually returns is a collection of objects with the tags of all the different objects that it found in the image, as well as the probability that that object appears in the image. So all I'm doing is, hey, if it's a hot dog, I'm going to tell the user, yep, it's a hot dog. If it's not, then I'm just going to say it's not a hot dog. But again, it also tells you whether the image contains pizza or sushi in this case, and tells you what how much confidence it has in that prediction. So transfer learning with super sophisticated pre-trained convolutional neural networks already trained by tech giants like Microsoft and Google, literally made easy. A few button clicks and uploads in a portal, then a few lines of client code to invoke that model. So let's see here. How are we doing on time? We're doing pretty well. We have about 10 minutes left, which is going to be a stretch, but let's see what we can do here. So another thing you can do with the Cognitive Services family of services and APIs is do text analytics. You can have it look at a document or set of documents and tell you what topics are discussed, what languages are there, what the key phrases in the documents are, or what the sentiment expressed in that, that text is. So if I wanted to do something like this, in fact, I'll use a real example. My son went to grad school to study data science, graduated a couple of years ago, but before his final year of grad school, he interned for a pretty large company that sells pet products. And one of the first tasks that they assigned to him when he came on board as an intern was to build an app that will look at the comments left on the company's website and score them for sentiment. So he built a model to do that. They're not terribly difficult to build, but you do have to know a little bit about machine learning and or AI to do it. With Cognitive Services and this text analytics API, it becomes trivially easy to take a sentence, a paragraph, an entire document, or what have you, and score it for sentiment. Here, you see I created a text analytics client object in C#. I passed the text that I wanted to analyze to its sentiment async method, and it returns a value from 0 to 1. The lower the value, the more negative the sentiment expressed in that text is. The higher the value, the more positive it is. Now, you can imagine that, let's say you had 1,000 tweets or 1,000 comments that you wanted to analyze. Rather than make 1,000 different calls to this API, you could batch them up this way. You take all the pieces of text or documents you want to analyze for sentiment, wrap them up in a multi-language batch input object, and pass them to the sentiment batch async method. And now what you get back is a collection of objects telling you how each of the documents scored for sentiment. So just a quick example there. I'm going to open a project that I call Tweet Analyzer. Now, to actually run this one, you not only need to go into the Azure portal and get a key for the text analytics API, you also have to register as a Twitter developer so you can access tweets by API. I've done that. And when I run this, what it lets me do is input a hashtag like, let's see here, how about hashtag Microsoft? What are people tweeting about Microsoft today? It pulls down the latest 100 or so tweets, and it passes them off to the text analytics API to analyze them for sentiment. And the aggregate score of all those was 0.59. So the sentiment is more positive than negative. And in fact, one thing you'll find in practice is anytime you batch analyze this from public data, anything in the neighborhood of 0.59 or 0.6 is pretty strongly positive, because there are people who say bad things about any company, any person for no reason whatsoever. Let's try this. How about, what's another one here? How about, how about SPCE? That's a stock I track as Virgin Galactic. Let's see what people are saying about Virgin Galactic today and about its stock. Pretty neutral sentiment, 0.51 on aggregate. So what did it take to do this? Most of the code in this app is there to go out to Twitter and pull down. It looks like I'm asking for the latest 99 tweets with that hashtag. But once I've pulled those tweets down and I've used a little bit of regular expressions to get rid of characters I don't need, URLs and things like that, then I pass it off to the text analytics API. All it takes to do that is create a text analytics client, call sentiment batch async. I then use link here to average the sentiment scores for all of the tweets that I uploaded in that batch, and I show that to the user in a message dialog. So again, pretty simple. I didn't have to build my own sentiment analysis model, didn't have to know anything about data science or machine learning. I just let Cognitive Services do that for me. So one last thing here. One member of the Cognitive Services API that I don't often hear people talk about, but that I thought might be interesting to you, is one called the Form Recognizer API. Now, one reason I thought this might be useful to you is because it's useful for us. One of our customers does a lot of work with the government, and they're required to keep documents and contracts and things like that for a period of like 30 years. So they have this massive warehouse of boxes with millions of paper documents that they're looking to digitize. So they went out to a couple of companies that got quotes for digitizing and putting in a database all that information. And it was quite expensive, way, way, way up in the millions of dollars. They talked to us and we said, well, you could do this really cheaply with the Form Recognizer API. What this lets you do very simply is this. You can upload forms to it that have been filled in with handwriting or typewriting or whatever, and it uses AI to learn what the structure of those forms is and to extract information from them, information that was added in. It includes some pre-built models. So if you want to do this with receipts or driver's licenses, for example, you don't have to do any training. You just upload the image, it figures out what it is, and returns information like the name of the person on the driver's license, the state where they're registered, and things like that. But the really cool thing about this API, by the way, there's a quick example showing how to use the built-in receipts model. The cool thing about it is that it comes with a tool at the URL you see here. I'm sure later they'll assign it its own unique URL. But it lets you upload forms, and it gives you essentially a graphical designer, so you can say, okay, this field contains the person's first name. This field contains a person's second name. This field is a free-form field where a person can write anything they want describing a product. And it learns from the training that you do. You can upload as few as 5 forms. Use this tool to tell the Form Recognizer API what the fields are, where they are, what kind of information they hold. Then you can upload millions of documents like it and it will go extract all of that information in them from them. And doing that from C# is as easy as it can be. I just create a form recognizer client object. Then I upload a scan of a form. It can be an image or a PDF, by the way, using the start recognize custom forms from URI async method. There's a mouthful for you. And then I iterate over the results to see what it returned. Here's a quick example, and I'll close off the slides after this. Let's go out to Visual Studio again. And this time I'm going to open a project named Form Recognizer Demo. And here's what I did. I trained a custom form recognizer model to recognize IRS Form 1040 ESs. If you do contracting, if you're a contractor or you do contracting on the side, you're probably familiar with that form. It's the IRS's estimated tax form. So after I did the training, I uploaded some sample forms so that it could recognize what's in them. And then I scanned some forms, some new ones that I didn't train it with. And let's see here. I should have some of them right here. Here we are, sample forms. So I'm uploading a form, not one that it was trained with, but one similar to what it was trained with. And it's extracting the information from it. It says, I got my name from the form as Jeff Procyse. It extracted my social security number. It missed my, because of my poor handwriting, it thinks my wife's name, Lori, it interpreted that as L-O-H. You can see it pretty much got everything else from that form. Let's try a different one here. I'll just grab another one. It's uploading to the custom model that I trained with the Form Recognizer API. And this time, once more, it pulls the information from that form. And notice that the information filled into the form is handwritten. Thanks to AI, this API is actually quite good at recognizing handwriting, even bad handwriting like mine. So what did it take to build that? Most of the work was just going into the Form Recognizer portal, uploading 5 forms and training the model, telling it what fields were there, what the data type was, where on the form it was located. Once the training was done, using it was as simple as this. Here, in this upload method, this is what gets called when I upload one of those forms. What I'm doing is creating a form recognizer client, then I'm calling start recognize custom forms async. Notice I'm not passing in a URI, I'm passing the actual form in the body of an HTTP post here. And when it comes back, IRS form data is a class that I've defined with all the different fields in the forms. Where did I put that? I actually put that in a different file. Should be in my models folder, I guess. Yeah. Here's what the class looked like. Just a simple C# class with properties representing the different elements that could be in that form. And when it comes back, I just go through each of those properties one at a time. These are the labels that I assigned to these properties when I train the model. Pull out the information. Here I'm just showing it on the page, but I could just as easily say drop that into an Azure SQL database or an Azure Cosmos DB database so that I could easily search that information or build a UI that facilitates that search for me. So it's certainly not all of the Cognitive Services APIs, but it is the ones that that I found to be useful, that I thought might be the most useful to you. One last thing I'll mention, there are APIs for doing real-time speech translation, for translating text from one language to another, for doing text to speech or speech to text. Here's just a quick example of how to convert English writing to French writing. It supports about 60 different languages, I believe. And for lack of time, I won't do that final demo, but I will show you this. In closing here, if you would like these samples that I've shown in this webinar, as well as other samples I haven't shown, go to my public Cog Services repo. Where is it? Looks like I'm in way too many repos. Here we are. The URL is github.com/jeffprocise/cognitive-services. I'm constantly updating samples there, adding new samples and things like that. It's a public repo, so anyone can access it. Feel free to go in there, pull this down, and play with these things for yourself. Remember that if you do that, you will need to get your own Azure API keys and plug into the code so that these will work. So that concludes my presentation. Are there any questions that I can answer before we part ways? Any questions or comments or anything else? Well, if not, remember, you can always reach out to me via Twitter or email. There's my email address again, right there. I'd love to help you if I can. We help customers with this stuff all the time, whether it's using AI as a service in Azure or AWS, or building custom machine learning models, or teaching our customers how to do that. We love doing this kind of stuff. If I can ever help you with anything, please feel free to reach out, and I'll certainly help if I can. So with that, I will end the webinar. Thank you so much for giving me your time today. I hope it's been useful for you, and feel free to reach out if you have questions or comments. Other than that, hope all of you have an awesome day. Thanks.